We have developed a system that allows the user to control the computer directly through electrodes. Electrodes are placed above and below an eye and to the left and right of the eyes. A clip electrode has been placed on the user's ear. The signals measured by the electrodes track eye and head movements. The electrodes allow us to determine the position of the eyes relative to the head. The top and bottom electrodes indicate the vertical position of the eyes and the head. The left and right electrodes indicate the horizontal position of the eyes and the head. Here we are displaying the vertical signal in blue and the horizontal signal in red. If the user looks up, the vertical signal rises. If the user looks down, the vertical signal drops. A quick peek in the vertical signal indicates an eye blink. If the user looks right, the horizontal signal rises. If the user looks left, the horizontal signal drops. The two signals are used to control the vertical and horizontal position of the cursor. The user is controlling the cursor by moving his eyes and head. Look left, the cursor moves left. Look up, the cursor moves up. The user is spelling out a message on the screen through the electrodes. A keyboard is displayed on the screen. The cursor is moved around the screen by the user by moving his eyes and head. If the user wants to select a letter, he looks at the letter. If the cursor is kept in a square by the user for a certain period of time, then the letter is added to the end of the message. A space key, a backspace key, and an end of message key are provided on the screen. Basically, the cursor is tracking eye movements. Nonlinearities or drifts in the signal can be corrected by the user with small movements of his head. The raw signal as displayed was jerky. We have been working on methods for smoothing out the signal. Here is an example of a damping function being applied to the incoming vertical and horizontal signals. Notice how the cursor movement is much smoother. Of what use is this system? We see potential uses in many areas. The system could be used with video games. Look to the left and the car you are driving on the screen moves to the left. Look right, it moves right. The system could be used in conjunction with a traditional keyboard for data entry. Look at the blank you want to fill in and start typing. No reason to take your hands off the keyboard to use the mouse. The system could be used to help the disabled interact with a computer or communicate with the outside world. The system could be used for the interactive exploration of large databases or for scientific visualization. Just look at a region of interest to see more and more detail. The system could be used for interactive television. Imagine an interactive home shopping channel where you can select items for purchase just by looking at them. Finally, here is the user playing tic-tac-toe with a computer. The user selects his move by looking at the place where he wants his X to appear.